In January 2026, at the World Economic Forum in Davos, President Donald Trump dropped a statement that immediately set the defense world buzzing. He wasn't talking about tariffs or trade deals. He was talking about a fighter jet. "They say it's the most devastating plane ever built," Trump said. "They called it 47. If I don't like it, I'm going to take the 47 off it." The remark was cryptic, but the message was clear. This aircraft, the F-47, was tied to his legacy, and by extension, to America's future air dominance. The F-47 isn't just another fighter program. According to defense insiders and aerospace analysts, it represents the United States' push into what's being called the sixth-generation air superiority era. Boeing was awarded the contract in 2025, reportedly beating Lockheed Martin, not necessarily because it had a better design on paper, but because it could deliver the technology fastest. What little is known about the F-47 comes from a mix of leaked budget documents, DARPA filings, and airframe patents. These hints suggest it's tailless, twin-engine, capable supercruise, and designed for long-range Pacific operations. Something the F-22 and F-35 cannot fully achieve. The urgency behind the program is strategic. U.S. reconnaissance in late 2024 revealed China's J-36 Ginkgo program, a massive tailless aircraft allegedly capable of long-range strikes across the Pacific. While much of the J-36 reporting is speculative, its existence spurred a reconsideration of air combat requirements. The F-22 Raptor and F-35 Lightning II were not optimized for the scale of Pacific engagement. Their ranges and payloads were limited compared to what a modern Pacific conflict might demand. The F-47, insiders suggest, is designed to operate from distributed island bases, strike at long range, and return without mid-air refueling, providing the United States with unprecedented operational flexibility. The Davos statement was more than political theater. By attaching his name to the program, Trump effectively created a form of accountability rarely seen in defense projects. While the F-35 became notorious for cost overruns and delayed timelines due to lack of centralized oversight, the F-47 has a clear figurehead responsible for its success. That kind of pressure, combined with Boeing's engineering capacity and prior DARPA demonstrator programs, makes the F-47 one of the most closely watched projects in global aviation circles, even if much about it remains classified. The F-47 program isn't just about building a faster plane, it's about closing a strategic gap. In December 2024, U.S. satellites and commercial imagery spotted something unusual in China's interior deserts. A massive tailless aircraft flying over highways in broad daylight. Leaked images circulated online under the codename J-36 Ginkgo. Its triangular delta-wing design and side-by-side cockpit suggested a focus on long-range strike and multi-crew operations. While analysts caution that these images could be prototypes, concept art, or even exaggerations, the implications were clear. China was signaling ambitions for a next-generation air superiority platform. According to experts, the J-36's rumored specifications should be taken with caution, but the strategic impact is real. A reported combat radius of over 3,000 kilometers would allow operations across the Pacific, including Taiwan, Japan, and contested maritime zones. For the United States, the existing F-22s and F-35s cannot match this combination of range and speed without extensive tanker support. The F-47 is being designed precisely to fill this gap, with a focus on extended supercruise, stealth survivability, and distributed operations from remote island bases, capabilities that turn raw numbers of aircraft into a decisive advantage in contested airspace. Beyond the numbers, the J-36 also represents psychological pressure. Chinese state media has publicly praised the aircraft as years ahead of American technology, mocking Western programs before they even take flight. This isn't just a technological claim, it's strategic messaging aimed at shaping perceptions of power in the region. In response, the F-47's development emphasizes survivability, speed, and lethality, ensuring that the United States maintains not just parity, but a credible deterrent capable of shaping Chinese calculations even before combat begins. The J-36 story also underscores a broader point about aerospace development in the modern era. Observers note that prototypes, X-plane programs, and classified demonstrators now exist in a blurred zone between reality and speculation. Programs like the F-47 benefit from years of secret experimentation under DARPA's next-generation air dominance initiatives. Hundreds of flight hours, extensive digital simulations, and testing of adaptive engines have already taken place, much of it invisible to the public. In contrast to the J-36, which may still be in early test flights, the F-47 is entering production with a known performance envelope, giving it a strategic head start despite the dramatic claims of adversaries. The F-47 isn't just about raw speed. It's about surviving in a battle space dominated by advanced air defenses. Traditional stealth fighters like the F-22 rely on polymer coatings that can easily degrade under heat and moisture, requiring constant maintenance. The F-47 tackles this problem with a revolutionary ceramic matrix composite skin, reportedly developed with input from researchers at North Carolina State University. Unlike traditional stealth paint, this material can withstand temperatures exceeding 1,800 degrees Celsius, allowing the aircraft to maintain stealth even while supercruising at Mach 2+. It's water-resistant, durable, and effectively makes the aircraft invisible across multiple radar bands. The tailless airframe is another critical innovation. Vertical stabilizers on conventional fighters create strong radar returns, giving adversaries a fixed point to track. By eliminating these surfaces, the F-47 reduces its radar cross-section while maintaining aerodynamic stability using active flow control, tiny jets of air along the fuselage and wings that adjust airflow in real time. This system allows for precision maneuvering without traditional control surfaces, a feature that could make it dramatically harder to target for modern integrated air defenses like China's S-400 equivalents or Taiwan's advanced missile batteries. Inside the fuselage, adaptive cycle engines, either the General Electric XA-102 or Pratt & Whitney XA-103, provide a combination of raw thrust, range, and electrical power unmatched in previous fighters. The third, variable bypass stream allows the aircraft to switch between high-thrust combat modes and efficient cruise modes, increasing operational range by an estimated 30%. The same engine also generates megawatt-class power for directed energy weapons, which could intercept incoming missiles mid-flight. These integrated systems blur the line between propulsion, energy generation, and survivability, turning the F-47 into a platform that is as much an energy node as it is a fighter jet. The combination of stealth, speed, and adaptive propulsion makes the F-47 more than just a plane. It's a system designed for modern, networked warfare. By the time a potential adversary detects the aircraft, it may already be coordinating autonomous wingman drones, designating targets, and engaging in electronic countermeasures, all while remaining nearly invisible on radar. The design philosophy here isn't just about outmatching enemy aircraft. It's about shaping the battle space, forcing the adversary to react on terms dictated by the F-47. The F-47 isn't just a fighter. It's a battlefield quarterback. Its primary advantage lies in its integration with directed energy weapons and autonomous drones, turning a single aircraft into a force multiplier that can engage multiple threats simultaneously. The ceramic skin and adaptive engines provide the power and thermal management needed to operate high-energy lasers. In practice, this means the F-47 could intercept incoming missiles mid-flight, effectively creating an active shield around itself. Unlike traditional countermeasures, which rely on chaff or decoys, the laser system offers near-infinite ammunition, limited only by electrical power generated in real time by the engines. Complementing the F-47 are collaborative combat aircraft, or CCAs. These autonomous wingmen, controlled by the pilot, serve two primary roles. The first, the Anduril Fury, YFQ-44A, is a fighter-like drone capable of dogfighting, launching missiles, and suppressing enemy air defenses. The second, the General Atomics YFQ-42A, functions as a long-endurance sensor platform, providing surveillance, electronic warfare, and additional strike capability. With one F-47 controlling 4 to 6 drones, the pilot effectively multiplies their impact, allowing small formations to dominate much larger enemy air forces. This distributed kill web isn't just theoretical. By combining high-speed stealth, long-range sensors, and autonomous drones, the F-47 can execute complex missions while minimizing risk to human pilots. In a hypothetical Pacific theater engagement, a single F-47 could penetrate an integrated air defense system, suppress radars, target enemy fighters, and launch precision strikes, all while remaining nearly invisible and coordinating multiple autonomous systems. The concept transforms air combat from individual dogfights into coordinated, networked operations where human decision-making is amplified by machine speed and reliability. The operational doctrine emphasizes survivability and efficiency. One pilot can effectively control multiple drones at a fraction of the cost of manned aircraft, allowing for attrition of expendable assets while preserving high-value pilots. This model contrasts sharply with traditional air forces that rely on large fleets of human-piloted aircraft. The F-47 system approach represents a fundamental shift in air warfare, where fewer platforms can generate exponentially more combat power through advanced technology, autonomy, and integrated systems. Skeptics have been quick to claim that delivering a fighter as advanced as the F-47 by 2028 is impossible. After all, the F-35 program took decades, faced cost overruns, and suffered from repeated delays. But the difference with the F-47 is that it's not being developed in the open. It has already been flying in secret. Under the Air Force's Next Generation Air Dominance Initiative, multiple X-plane prototypes were built and tested by Boeing, Lockheed Martin, and DARPA as early as 2020. These weren't just models. They were full-scale, fully functional aircraft. Hundreds of flight hours have already been logged, validating stealth, flight characteristics, and sensor systems. By front-loading risk, the Air Force ensured that the first production F-47 was built with technologies already proven in the air. The engineering and manufacturing development phase, now underway in St. Louis, isn't about testing experimental systems. It's about creating operational aircraft ready for deployment. General David Alvin publicly confirmed in September 2025 that the first F-47 will fly in 2028, with initial operational capability expected by 2030. This timeline isn't arbitrary. It's a strategic response to potential threats in the Pacific. The compressed timeline also reflects lessons learned from the F-35 program. Instead of designing, testing, and building simultaneously, which caused massive delays in the past, the F-47 program tested and validated critical technologies in secret before moving to production. Flight characteristics, adaptive cycle engines, autonomous drone control, and stealth coatings have all been refined in hundreds of digital twin simulations, ensuring that production aircraft are not experimental prototypes, but operational platforms from day one. Strategically, the program's timeline is designed to counter predicted threats. Senior military planners, including Admiral Phil Davidson, have warned that China could attempt a Taiwan contingency within the late 2000s. By achieving operational F-47 capability by 2028, the United States signals a credible deterrent. A fighter capable of dominating airspace, coordinating autonomous swarms, and operating without tanker support, all of which changes the calculus for potential aggressors. In effect, the program timeline itself becomes a tool of strategic influence, shaping adversary behavior even before the aircraft ever fires a weapon. The F-47 isn't just another fighter jet, it's a statement of strategic intent. Its existence alone alters the calculations of any potential adversary. By combining extreme speed, long-range capabilities, stealth, and autonomous wingmen, the F-47 fundamentally changes the balance of power in the Pacific. China's mass production approach, relying on hundreds of J-20s and prototypes like the J-36, faces a stark contrast. The United States is building fewer aircraft, but each one is a force multiplier capable of commanding multiple drones, coordinating strikes, and suppressing enemy defenses with unprecedented precision. Deterrence isn't about having the most planes, it's about making the cost of aggression intolerable. A single F-47, with its swarm of CCAs, can neutralize entire air defense networks, eliminate key fighter threats, and secure control of contested airspace, all while remaining almost invisible to radar. This capability signals to Beijing that any attempt to assert dominance over Taiwan or challenge U.S. interests will be met not with incremental resistance, but with a rapid, overwhelming technological response. The threat isn't hypothetical. It's embedded in the aircraft's design, the production schedule, and the integrated swarm tactics. The program also reshapes operational doctrine. Traditional air forces rely on numbers, saturate the skies with manned aircraft, attrit enemy systems, and slowly gain the upper hand. The F-47 introduces a new paradigm: efficiency through automation, precision, and coordination. Its pilot becomes a battlefield commander, orchestrating a networked kill web that exponentially increases combat effectiveness. One F-47 and its wingman drones can achieve what would have required multiple squadrons in the past. This shift isn't just tactical, it's strategic, sending a clear message to any potential aggressor that technological superiority can outweigh numerical advantage. Finally, the F-47 serves as a signal beyond the battlefield. Its development timeline, advanced capabilities, and planned deployment act as a tool of coercion and reassurance simultaneously. Allies gain confidence knowing that the U.S. possesses a credible, operational air superiority platform capable of defending shared interests. Adversaries are forced to reconsider timelines, strategies, and the risks of military escalation. By 2028, the F-47 is set to redefine air dominance, not through numbers, but through intelligence, autonomy, and sheer technological superiority. By 2028, the skies will tell a new story. The F-47 Phoenix isn't just a fighter jet. It's the culmination of a decade-long secret program, a fusion of advanced materials, adaptive engines, autonomous systems, and directed energy weapons. Its arrival signals more than operational readiness. It represents a shift in how wars are fought and how air dominance is maintained. China's J-20S and J-36 prototypes may dazzle in public displays, but they are fundamentally different. They are unproven, reliant on human pilots, and lack the integrated swarm capabilities that give the F-47 a decisive edge. The political dimension is just as significant. By linking the aircraft to the 47th President, Donald Trump, the F-47 program introduces an unprecedented level of accountability and urgency. Boeing isn't building a plane in the abstract. They're delivering a legacy. The president himself has staked his reputation on its success, adding pressure that ensures milestones are met on schedule. Unlike previous programs, where delays and budget overruns went unpunished, the F-47 carries both technological and political stakes, aligning national interest with corporate performance. Operationally, the combination of advanced stealth, supercruise capability, ceramic matrix composite skin, and adaptive cycle engines allows the F-47 to fly farther, faster, and more survivably than any existing platform. Its ability to coordinate multiple autonomous drones transforms the battlefield, turning one aircraft into a node that can project force across hundreds of kilometers without exposing pilots to unnecessary risk. In essence, the F-47 is not just a fighter. It is a command and control system in the air, capable of simultaneously shaping battles and defending assets with unprecedented precision. Strategically, this changes the calculus for adversaries. The mere presence of the F-47 Phoenix in the Pacific serves as a deterrent, compressing timelines for potential aggression and signaling that any attempt to challenge U.S. air superiority will face overwhelming, integrated, and technologically superior forces. By the time any adversary detects a threat, the F-47 will have already executed its mission, leaving decision-makers to react to a new reality. The window for successful aggression has narrowed dramatically. The F-47 isn't just about winning the next air battle. It's about securing decades of air dominance. It's about integrating technology, strategy, and accountability to produce a system that multiplies both lethal and defensive capabilities. By 2028, the F-47 Phoenix will not only fly, it will define the future of air warfare, a testament to American engineering, foresight, and strategic planning. And in that future, the 47th President's name will forever be associated with the plane that reshaped the skies.